Welcome to Anselm Griffin's occasional series of YouTube tutorials featuring Matlab. Today we're doing a regression question, a simple linear regression. Well, not simple linear, we have a simple multiple linear regression. Okay, just to say I've done one more here on stepwise forward and a backward elimination regression, just to, in case that helps. So we can shut that down. So let's look at our workflow here. We have our steps here. I've published it into a PDF. So Matlab comes with this ready-made table of hospital values. It's an Excel format file. And we read it into a table like so. And we just showed the first record there. And that's Smith, he's male, he's 38, he's 176 pounds, etc. And we're trying to work out our model here. Our systolic blood rate is dependent on age, weight, sex, and whether you're a smoker or not. And we, just to say here, just before we go on, we make smoking a nominal value, yes or no, or a binary value, whichever way you want to look at it. And likewise, for sex, that's a yes, no. There's our model here. Our systolic pressure is the constant plus sex plus age plus weight plus smoke. And there's our constant is 118. Our slope for the sex is that. Slope for the age is that. Slope for the weight is that. And the slope for the smoking is that. We get an R-squared value of 0.508. So more or less 50% of the systolic blood rate can be accounted for by the model. And adjusted R-squared, if you know your statistics lecture, that takes into account the number of predictor variables. So what we want to try and do is get a high an R-squared rate as possible with as few as predictors as possible. We look at what the t-stat and the p-values do for us in a minute or two. But before we do that, let's look at some of the outliers. So we plot the residuals there. Let's just go down and have a little look at the plot. There, and what we're going to do, just for the sake, we're going to say we're going to get rid, I should say, a residual of 12 or more. So let's go back to there. So we plot the model. Our model.residuals.raw greater than 12. Find the outlier. And then we're going to remove it, fit LM, and exclude 84. We know it's 84 there, row 84. And we just spit out 84 just a chance. So that's it. And you see there, exclude is true. Okay. The histogram of the residuals we've seen before. Now, we want to try and reduce the number of predictors. So normally when I did statistics way back in the 80s, you'd have to do this one step at a time, but Matlab, you can say we'll take it up to 10 steps, and Matlab or whatever other package you're using, or SPSS would do the same thing. We're just doing it in Matlab. So, and then we're going to plot the residuals. So let's just have a little look there. So we gave it 10 steps, and it came up. I just slow down here because it broke across the page. We've got our R-squared up to 53.6, and the adjusted R-squared is very near the R-squared because why? Because we only have the systolic blood pressure is the constant plus the age of smoke. We've removed two of the predictors. The slope for the predictor, the slope for the age is that, and the slope for the smoking is here. And the intercept value is 115.11. And you see here that the F value is 55.4 and the P value is 1 by 10 to the minus 16. So just, what does that mean? If I just go to here, I found these set of notes. If you remember, what's the null hypothesis? That B1 equals B2 equals B3 equals whatever equals 0. And the alternative hypothesis is at least one of the b's equals 0, or at least one of the b's or the slopes, makes a contribution to the model. So the null hypothesis is that none of the predictors have any influence, have any bearing on the systolic blood pressure here, and HA is at least one of them. So if we just go back to here, just to pause for breath a little, the p-value is 1 by 10 to the minus 16. Well, not 0, but very, very close to it. So what's that saying in English? The probability of this being true, the probability that of B1 equals B2, why is that? Remember here, smoke and age, so there's only two predictors. The probability of B1 equals B2 equals 0 is 1 by 10 to the minus 16. So that's very, very small. And normally the significance level is 5% or 0.05. So the null hypothesis is they have no effect. So, and since the probability of that is 1 by 10 to the minus 16, which is way, way less than 5%, we have evidence to reject the null hypothesis. So in plain English, we think at least one, if not both, of age and smoking has a bearing on systolic blood pressure. Say you get 4 new people with their ages, and then their smoking is there. So they are a smoker, they're not a smoker, they are a smoker. So we bang in these values here, f of al, function evaluate the model, which we've described, their ages and their smoking, and there's the suspected, or the likely, the most likely outcome of the systolic blood pressure is there, and then we can just share it there, or we can print it and just let you see the answer there. Hope that helps a little. Thanks very much for listening.